back to my YouTube channel. I am Meghana Vijay from Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Computer Science and Engineering, 3rd semester CSE branch. Now I am going to discussing about the subject is mathematics. In this subject, the subtopic is exponential distribution applications. First of all, I would like to give the introduction about exponential distribution. Exponential distribution is a continuous probability distribution that is widely used to the time or space between events in a process where events occur independently and at a constant average rate. It is commonly associated with the concept of waiting time for an event to occur, such as the time until a radioactive particle decays, the time until a customer arrives at a service center, or the lifespan of certain mechanical or electronic components. Mathematically, the exponential distribution is defined by its probability density function, f of x is equals to lambda e power lambda x, where lambda is greater than 0 is the rate parameter, which represents the average number of occurrences per unit of time or space. E is the base of the natural logarithm, approximately equal to 2.71828. The cumulative distribution function of the exponential distribution is f of x is equals to 1 minus e power minus lambda x. The exponential distribution is a special case of the gamma distribution and is closely related to the Poisson distribution. In fact, if the time between consecutive events follow an exponential distribution, the total number of events in a given time interval will follow a Poisson distribution. Relationship to other distribution. Poisson distribution. The exponential distribution is related to the Poisson distribution. If the time between events follow an exponential distribution, the number of events in a fixed time period follows a Poisson distribution. Gamma distribution. The exponential distribution is a special case of the gamma distribution with the shape parameter equal to 1 and the properties of exponential distribution. Cumulative distribution function f of x is equals to 1 minus e power minus lambda x for x is greater than or equal to 0. Mean and variance. The mean or expected value is 1 by lambda. The variance is 1 by lambda square. Memoryless property. One of the defining characteristic of the exponential distribution is its memoryless property. This means that the probability of an event occurring in the future is independent of any previous occurrences. The exponential distribution simplicity and memoryless property make it a powerful tool for modeling a variety of real-world processes where events occur continuously and independently over time. And the applications of exponential distribution. The exponential distribution has a variety of applications across different fields due to its properties, particularly its memoryless nature and suitability for modeling time-to-time event data. Here are some notable applications are there. Reliability engineering and failure analysis. Lifespan of products. The exponential distribution is used to model the time until failure of products or systems that have a constant failure rate. This is applicable for items that do not wear out over time, such as electrical components or mechanical systems that exhibit a random failure pattern. Predicting mean time to failure. In reliability engineering, the exponential distribution helps calculate MTTF, which is essential for planning maintenance schedules and improving product designs. Queuing theory. Service systems. In systems where customers or tasks arrive randomly, such as in banks, supermarkets, or call centers, the exponential distribution can model the time between customer arrivals or the time taken to serve a customer. Telecommunications. Used to model the time between packet arrivals or call arrivals at a switch in network and communication systems. Finance and risk management. Time between insurance claims and modeling interest rates. Time between insurance claims are in actuarial science. The exponential distribution helps predict the time until an insurance policy holder files a claim, which assists in determining risk and setting premiums. Finance and risk management. Time between insurance claims. In actuarial science, the exponential distribution helps predict the time until an insurance policyholder files a claim, which assists in determining risk and setting premiums. Modeling interest rates. Certain stochastic models use the exponential distribution to represent the waiting times for changes in interest rates or other financial events. Biology and medicine. Survival analysis. In medicine research, the exponential distribution is used to model the time until an event such as death, disease reoccurrence, or recovery. It is particularly useful when the hazard rate risk of the event occurring is constant over time. Modeling time until cell division. Biological process like the time until a cell divides can be modeled using the exponential distribution when the process is as a constant rate. Operational research. Inventory management. The distribution can help model the time between restocking items, enabling business to optimize inventory levels and reduce holding cost. Resource allocation. Used to analyze and optimize resource allocation in operations, where the time until resources are requested can be exponentially distributed. Physics. Radioactive decay. The time between decays of radioactive atoms follows an exponential distribution due to the constant probability of decay over time. This application is fundamental in nuclear physics and related fields. Photon emission. The time between photon emission and excited atom can be modeled by an exponential distribution, making it relevant in quantum physics. Computer science. Algorithm performance. In stochastic algorithms, the exponential distribution may be used to model waiting times or timeouts in distributed systems. Simulation. The exponential distribution is frequently used in simulations to generate random time intervals between events for modeling various real-world processes. Transportation and logistics. Public transport schedules. The waiting time for buses, trains, or other public transport modes can be modeled using an exponential distribution when vehicles arrive at a constant average time. Traffic flow. Used to analyze traffic patterns and time interval between vehicle arrivals at an intersection or toll booth. Environmental science. Natural events. The time between certain natural phenomena such as earthquakes or volcanic eruptions in areas with a constant event rate can sometimes be modeled using an exponential distribution. Resource depletion. In studying renewable and non-renewable resources usage, the distribution helps model the time until a resource reaches a certain threshold. Key reasons for its use. Simplicity. The mathematical simplicity of the exponential distribution makes it easy to work with for deriving other statistical properties. Memoryless property. The property that the probability of an event occurring in the future is independent of the past makes it ideal for modeling process where history has no impact on future outcomes. Finally, I am giving conclusion about this. In conclusion, the exponential distribution is a versatile and widely applicable probability distribution that plays a critical role in various fields such as reliability engineering, queuing theory, finance, medicine, and physics. Its defining features simplicity, constant hazard rate, and the unique memoryless property makes it an ideal tool for modeling process where events occur continuously and independently over time. The distribution's mathematical properties, including its probability density function and cumulative distributive function, facilitates straightforward calculations and interpretations. As a result, it is highly effective for analyzing waiting times, predicting failure rates, and simulating real world phenomena across different industries. Understanding and applying the exponential distribution empowers researchers and professionals to make informed decisions, optimize operations, and enhance predictive modeling for a range of processes where time to event data is essential. Thank you for watching, guys.